Okay, we've got integration by parts. This is an example I'm going to do in just a moment. But before we do the example, we got to talk a little bit about what equation are we going to play with. Right? So we have to rely on this equation. The integral of u dv equals u times v minus the integral of v du. Right? Think about it. When we have the variable x, if we need another one alphabetically, we say y. If we played with f of x for a function, alphabetically after f we go to g. So if we use u as a universal variable, the next one of course is going to be v. Now when I'm actually looking at this, the u is just going to be my x. My dv is going to be e to the x dx. So that's the example we're going to try to work with. However, before I dive right into the example, I want to briefly let you know where this crazy equation is coming from. We spent a few months doing nothing but taking derivatives. And remember, if we have something like this, when we took the derivative, I took the derivative of u times v plus u times the derivative of v. Right? You got to take the derivative of the first thing, leave the second unchanged, put a plus sign, first unchanged, derivative of the second. Now if I integrate both sides, oh hey, there's a plus sign, that means I can break it up. Looks like I forgot to put the little dot for a time symbol on that one part. It's okay. If I integrate dy, of course I just get y. Of course, hey, wait a minute, we knew what y was. Y is u times v, right? If I look up to the top there, it says y equals u times v. Let's make that substitution. Now I can subtract the integral of du times v from each side. Let's tidy that up a little bit. All right, I get rid of the dots for multiplication. Also notice I put v du in our more logical order. And so that's where this crazy equation comes from. All right, so if I encounter the integral of u dv, it is equivalent to u times v minus the integral of v du. Okay, this is integration by parts. So let's get back to this example and let's see how I apply this wonderful equation. Now again, I'm going to have my u be equal to that x. My dv will be e to the x dx. Right, so my u is x, my dv e to the x dx. Now let me look at the rest of the equation, make sure I have all my pieces. Okay, the first thing I see is a u. Okay, I've got a u. Hey, I also need a du. Do I have a du? No. So how do I get a du? Well, let's take a look at that u equals x, and let's take the derivative of u with respect to x. Of course, the derivative of x will just be 1. Multiply each side by dx. 1 times dx, yeah right. 1 times dx, that'll just be dx. There, I've got my du. Anything else in that equation I'm missing? Yeah, look, I need a v. How am I going to get v? Well, let's integrate. If I integrate dv, I'm just going to get v. And if I integrate e to the x, well, I just get e to the x. So I've got all my components now. Okay, so let's see if we can actually write out what we need. It says if I've got the integral of u times dv, which is what we have, it's equal to u, okay, and that's x, times v. Okay, that's e to the x. Then there's a subtraction symbol, keep the subtraction symbol. Then I see an integration symbol, keep the integration symbol. V, well, v is e to the x. And now du, well, my du is a dx. Now the x times e to the x is just going to sit there, but I can integrate e to the x, right? If I integrate e to the x, I end up with e to the x. Oh, don't forget the plus c. Is that really the answer? Well, let's check. Let's pretend y equals x e to the x minus e to the x plus a constant. Okay, take the derivative of y with respect to x. Okay, I gotta take the derivative of the first part. Derivative of x, of course, is 1 times, leave the second part alone, leave the e to the x alone, plus, now this time I'll leave the first part alone, so that's x, times, now I gotta take the derivative of the second part. The derivative of e to the x is e to the x. I see a subtraction symbol, so I better keep the subtraction symbol. Now, what is the derivative of e to the x? Well, that's going to be e to the x. And now, what is the derivative of a constant? Well, 0, so I don't need it. Let's tidy up that answer a little bit. 1 times e to the x is e to the x. X times e to the x is x e to the x. And of course, I still have my subtract e to the x. Hey, a couple things cancel out there. Look what we're left with. And sure, what we have there is what we started with in that integral. Right? So yes, it checks out. If we integrate x e to the x dx, the solution we got when we take the derivative takes us back to x e to the x. So much fun, I think we should do one more example. What if I've got x times sine of x? Okay, again, let me see if I get all my pieces here. I'm going to let my u be x. I'll let my dv be sine of x dx. Right, so u is x, dv is sine of x dx. Do I have all the pieces I need? Well, let's look at the rest of the equation. Do I have my u? Yeah, I've got a u. Do I have my du? Whoop, nope, better get my du. Take the derivative of u with respect to x. Surprise, surprise, it's going to just be dx. It also looks like I need a v in that equation. So if I've got dv, I need to integrate that. Right, so if I integrate dv, right, that's kind of like 1 dv. Of course, if you integrate 1, you just get the variable, so v, right, the derivative of v is 1, also known as, that 1 dv there. Of course, if I integrate sine, I get negative cosine. Okay, so I've got my pieces. Let's see if I can fill them in. Okay, I got integral of u times dv equals, now I need my u, that's x. I need a v, and that v is going to be negative cosine x. I see a subtraction symbol, I better hang on to that. I see an integration symbol, better hang on to that. V, well, again, that's negative cosine of x. Du, and of course du is dx. Okay, so what do we have here? Well, x times negative cosine of x will be negative x cosine of x. And then I've got that subtraction symbol. Don't lose that subtraction symbol. Now when I integrate negative cosine of x, I'm going to get negative sine of x. Let me see here. Hey, we've got that plus c. Don't forget about the plus c. And it looks like I've got subtracting a negative x, that becomes a positive. Right? So there's our answer. Negative x cosine x plus sine of x plus c. Does this thing check out? Notice Peppa Pig just flew in on a sine wave. Was that kind of cool or what? Okay, so let's check our answer here. If y equals negative x cosine of x plus sine of x plus c, the derivative of y with respect to x, here we go again. Take the derivative of that first part, which is going to be negative 1, times, leave the next part alone, so leave it as cosine of x, plus, leave the first part the way it looks, negative x, times, take the derivative of the second part, so the derivative of cosine is negative sine. Then I see plus sign. Derivative of sine is cosine. Derivative of the constant is 0, so I don't need that. I can tidy some things up here. Negative 1 times cosine of x is negative cosine of x. Negative x times negative sine of x becomes positive x sine x. And of course I've got that cosine of x back there. And that simplifies to become x sine of x. And sure enough, that matches what we started with. So if I integrate x sine of x, I got a solution. I took the derivative of the solution, and sure enough, back where I started. So we have some, what does that even, oh, it's scrambled. Okay, it's got to unscramble itself. We're going to have a worksheet. And then if you need some assistance setting the dinner table at home, right, thought we want to just kind of review and remind ourselves what all these implements are. You got your fork, your threek, your took, your wunk, and your zerook. Right? The fork has 4 sharp points. The threek has 3 sharp points. The took has 2 sharp points. Although some people will contest that should be pronounced twalk instead of took. Go figure. The wunk, of course, just has the 1 sharp blade. And the zerook, that is the safest implement because there are no sharp points on that one.